you can refer back to it later. Right, so in geometry, the basics of sort of geometry are going to be points and then line segments joining those points. So a point will be always represent, I don't think that's good English. A point will always be represented by a dot. And so if we have a look at our diagram that we have here, this A and this B, those are points. Those points are always going to be labeled with a capital letter. And you'll see in a second, that's going to help us refer to specific lines that we're talking about, or refer to specific angles that we're talking about. And so those points are really important that we know how to identify them. From points, we can then draw line segments. So we can join 2 points, and that is then creating a line segment. So in this case here, if I join the 2 points AB with a line, I've now created the line segment AB. So when we label lines, we are using the 2 letters that the line is created between the points of that line segment. Okay, when we then get to angles, and this is what we're going to now start getting into today, angles are created by arms. So basically, it's 2 arms that meet at a common point to create an angle. So you'll see in this diagram down at the bottom, this has got quite a bit of terminology going on in it, but it explains all of these things. So the line AC, and the line AB are 2 arms. They meet at a common point, so what we call a vertex, because that is where those 2 lines meet. And when we then have our 2 arms meeting at a common point, the space between those arms is the angle that we're looking at. So the angle is basically the space between 2 line segments or 2 arms. Now, for the most part, guys, we don't really use our geometry sets anymore. It's going to be more just calculating and working out algebraically. So you don't really need your mathematical sets anymore. It's very rare that we ask you to measure an angle. That's not to say that we can't, but it is quite rare. Generally, we don't do that. So it's important to maybe have a math set and have a protractor, but I wouldn't stress too much about it because we do sort of just calculate the angles anyway, and we don't need to measure it. Right. I can see a lot of people are saying they haven't done geometry. That's fine, guys. Don't worry. If you haven't done it at school, you will eventually. And so you will already have had a head start sort of on the geometry section. Okay. This is the section we're doing right now. So you've got a little bit of a head start. And for those of you who are doing it at school, hopefully now this can clarify any questions that you might have. Okay, cool.
Sorry to just say, I just wanted also to add, guys, that don't worry. Maybe even your school, they don't even call it geometry yet. They might be calling something else, but it's exactly the same. So most of you will end up realizing what we talk about when we're trying to calculate angles. And also, if you haven't done it, eventually you will do it. And the nice thing is that if you haven't done it in class and you're doing it here, when you do it in class, you'll definitely ace it. Okay, so let's do this.
Exactly, guys. And like I say, geometry is super important. So even if, like Yolanda says, you haven't started it yet, you will eventually do it in maths. And so this is at least a little bit of a step in the right direction, a step into what we're going to see. Alrighty, so there's just one more important thing that I would like to point out, and that's just how we label angles. Now, the reason I want to point this out is, again, because as we get more and more into geometry, as the diagrams become a little bit more complicated, we need to be very clear about the angles we are working with. And so being able to label an angle is very important. Alrighty, so lots of different ways, and it will very much depend on the diagram that you're working with. If we have a look at the first way we can label an angle. So I'm over here, we can label an angle with a capital letter. So basically, if we are referring to or wanting to work with this angle A over here, we can call that angle A. Now you'll see in like the whole little note, and again, don't write this down, take a screenshot. You don't have to copy this down and learn it off by heart. When we write this down, we can use the notation angle, which is like a slanted L and then A, but most of the time the way we notate angles is with like a little hat on the letter we're referring to. So in this case, we would call this angle A. So A with a little hat on it. telling me that I'm talking about angle A. All right. Now, this isn't very commonly used as our type of naming of angles, mostly because oftentimes there will be more than one angle at a common point. And so we need to then be very clear about the angle that we are talking about. So if we go over to the next way we can label an angle, 3 letters is often the way that we go and label angles. So if again, we are talking about this green angle over here, whilst yes, we can label this angle A, oftentimes we use 3 letters. Now the 3 letters that we use are basically the points along the arms making up the angle. So if we have a look here, we start at point B, we move along the arm to point A, and we move along that second arm to point C. And we can see that the angle is created at that vertex A. So the angle we are working with is angle BAC. Now you can see that the little hat is on top of the A, telling me that the angle is at the vertex A. Okay, so that is how we mostly label angles. Sometimes we're nice to you and we give you numbers on the angles, which is absolutely fine. So a third way we can label angles is with a capital letter and what we call a subscript. That subscript is basically just, this is angle A1, A2, A3, etc., etc. So again, if we look at this diagram and we look at this specific angle over here, we can see that that angle has been created at the point A, right? We can see that because there's point A. But we can see at point A, we actually have 2 angles. We've got this blue one that I've colored in, and we've got the angle on the other side of it. And because I've got 2 angles at the same point, I need to be very clear about which angle is which. So I can, if I give you numbers on the diagram, you can use A1 and A2. Otherwise, as we know, we can use our 3 letters. So angle A1, so the blue one I've colored in, is BAC, because those are the points along the arms that create my angle. And then the other one would be DAC. Now, the order of those letters does not matter. As long as your middle letter is the point where the angle is. So in this case, A must be the middle letter. And that middle letter has its little hat on it to show that we're talking about that angle. The order doesn't matter. So you could say here angle BAC, or you could say angle CAB. That is absolutely fine. It is exactly the same angle. So the order you put the letters in isn't overly important. We don't really say alphabetical because obviously A needs to be in the middle, so it can't be alphabetical in this case. So as long as the correct letter is in the middle with a hat on it, absolutely fine. Right, like I say, the numbers won't always be there. Sometimes we won't give you those numbers, and then knowing how to label your angle with the 3 letters is super important. And guys, as we do this more and more, you'll see what all of these labels mean. It's just really important, again, like the notation and the terminology. If you see something like this, you're not panicked. And if you need to label an angle, you know how to do it. Okay, so those are the 3 most common ways. Most commonly, we will use either the 3 letters or the letter with the number. Okay, sometimes we can give you a variable, which then you can just use the variable. So sometimes I might go and just label the angles with X's and Y's or with whatever variable we want to work with. So this little purple angle here is angle X. And so then we just have X as our angle. All right. So sometimes we are nice and we give you the variables and we give you the numbers and all the rest of it. And it's easier to label, but not all of the time. So just have a look at your diagrams when you're given them and just make sure that if you have sort of lots of angles at the same point, you know how to label it if it's necessary. Sometimes it won't be, but if you do need to refer to a specific angle, we need to know how to do that. Right, so I'll leave that up there for 5 seconds if you need to take a screenshot. I'm hoping that, as I've seen questions in the chat, I've tried to answer them, but I'm hoping that all of your questions have been answered. So we can use a capital letter, the 3 letters and the capital letter and the subscript, so the blue and the green are the ones we use most commonly. And the 4th one, using variables, is basically I can just label an angle X and Y, and then we just refer to angle X or angle Y. This last one is what we'll do in the first couple examples. So you can just use X and Y as your angle. That's absolutely fine if we give it to you like that. Okay. Right, so let's get into these examples. Now, in geometry, what happens is we need to have a statement that we're going to make in order to solve for an unknown angle. But the second I make a statement, you have to give a reason, okay? You will see, especially in grade 8, you get marks for your reasons. So this sort of statement over here, you have to give a reason. It's very, very important. And in grade 8, like I say, often we give marks for those reasons. So if you leave off the reason, you might lose a mark, and that's a silly reason to lose a mark. Okay, now the reasons I'm going to give you in our lessons will always be in like this little block over here, and we're going to use them lots and lots and lots, so you will learn them. If you want, it might be an idea to have like a little list for yourself of all the geometric reasons that you need to learn, and sort of just as a reminder for yourself of, okay, if I'm in this situation, I would use that reason, or another situation, you just have like a little list of reasons that you're going to work with. So we make a statement and we give a reason for that statement. So the first reason that we're going to talk about is angles around a point. Now, what's quite nice in maths is we don't really stress too much about English, which is great. I don't have to write out the word angles. I can use that little lopsided L. I don't have to write out the word point. I can abbreviate that to PT. So quite nice. You don't have to write these long reasons. You can just abbreviate it. All right, so our first reason is angles around a point. Now, what we know is that if we go all the way around a point, I'm eventually going to create a circle. And we know that a circle contains 360 degrees. So if I go all the way around one single point, I have gone 360 degrees. Now, what this is this is a revolution, okay? Hopefully you can see this. And we know that a revolution is 360 degrees. So anytime we are working with angles or an angle around one central point, we are working with a total of 360 degrees. So let's have a look at some examples of how we would now use this reason in order to solve for an unknown. Okay, so we're going to start off quite easy, and then we'll get to slightly harder ones as we go along. Our first question here is, in all of these, we're solving for our unknown. Okay, now, obviously you need to draw the diagram. Don't stress about making it absolutely perfect, just so that you can see what's going on. Now, this is an example of labeling angles with the fourth way that we said we could label angles with just a variable. So what I'm asking you to find in this case is the size of just this angle X over here. Now we know that we have got a common point, right? That little blue circle over there, that's my common point. And if I go all the way around that point, I'm going to end up with 360 degrees. Now I can see that I've already got 310 degrees of those 360. So I just need to figure out how many degrees I'm missing to form that full circle, to form that full revolution. And I can see some wonderful answers coming through here on the chat. There's many ways you can set this up. I'm going to do it like quite step by step and break it down quite a lot. But obviously, guys, in the simpler questions, if you are happy to go straight to your answer with your reason, that is okay. All right, so what we know here is that if I take the angle X and I add 310 degrees, I have to get to 360. Right, now this is what we call our statement. You don't have to label like this in your test. I'm just showing you what it is. We've made a statement, and now we have to give a reason for why I've made that statement. So why have I said that X plus 310 must equal 360? Well, I've said that because we know that angles around a point must equal 360 degrees. Now remember, it's a reason. You don't have to write a whole long paragraph. You just put your reason in brackets. And I've now said, okay, well, I'm saying that X plus 310 equals 360 because I know that angles around a point equal 360 degrees. So I've set up a nice, easy equation for myself. I want to get X alone. So I know that using inverse operations, what I now need to go and do is subtract 310 degrees on both sides. And guys, remember, this is an angle, so it does actually have units. We need to remember that degree symbol. And so x is equal to 360 minus 310 degrees, which gives me that x is equal to 50 degrees. Now this makes sense. If I go and replace this x with 50 degrees, if I say 50 plus 310, I do get back to 360, which is my full revolution all the way around the point. And so it makes complete sense that x is equal to 50. So what's really important there, guys, is that once you've made your statement, you give your geometric reason. Those are so, so important. When you get up to like grade 10, 11, 12, what's going to happen is the second you start missing out reasons, you're going to lose more and more marks. So remember always to have that reason. Alrighty. Can I just get a thumbs up, thumbs down? You can put it in the chat or you can do it on your screen. How are you feeling after that first one? I know geometry isn't everyone's favorite sometimes, and that's absolutely okay. It will become your favorite.
Guys, so I'm so proud of you. So another thing that I want to remind everyone is that when Teacher Sam is busy talking and you have your hand up, please try and put your question on the chats, because either I can respond to that or Teacher Sam can respond to that. Like this, I don't cut Teacher Sam on the way that she's talking, you know. So please do put your questions on the chat, and also you can raise your hand until your question is answered. But at least you make sure that you cover both platforms, okay? And also another thing, please do not panic. If other students are busy putting an answer that you don't understand, it doesn't necessarily mean that what you have is wrong, because remember, they are also learning, and their explanation doesn't mean that it's correct. So don't rely on what other students are saying on the chat. Rely on what Teacher Sam is teaching you and what Teacher Sam is saying, okay, my people? Because I know I have like clever brains over here, and you're allowed to ask questions, okay? So do not panic. Don't panic. And we're doing more and more exercises to make sure that you understand 100%.
Guys, just because now Yolanda said it and I've seen a question come up in the chat, what's really important is that I am not saying that every angle is 360 degrees. I'm just saying that if we've got one point and we're working with angles all the way around that point, that is equal to 360. We're going to deal with other ones where we don't work with 360 because it's a different type of angle. So if I'm talking about an angle with a revolution, so all the way around one central point, that's when I'm talking about 360 degrees, okay? Because I'm talking about one revolution, a central point, and all the way around that central point, okay? We're going to do more examples, so don't stress. Okay. Lungile, I see your hand is up. Do you have a question for us?
Yes, ma'am.
What's your question?
Ma'am, I just wanted to ask that where do you get 360 degrees from?
Okay, so remember, like I say, what we're working with is basically a circle. It's a revolution. So because I'm going all the way around a circle, that whole measurement around a circle is 360 degrees. So that's why I'm working with 360, because if I take the 310 that I have and I add the x, it actually creates a full circle. And so that's why I work with 360 degrees.
Okay, ma'am, thank you.
Okay, so guys, what's really important is, like I say, if you've got one central point and then you're working with angles all the way around that point, if you add up all of those angles, you will get 360 degrees. So it doesn't matter how many angles you have. I can have a central point and I can have lots of different angles coming from that central point. But if I add all of them up, I will still get 360 degrees because the circle is made up of 360 degrees. Okay, we are going to get to harder ones, but this is sort of just introduction to geometry. So we're going to get there. Alrighty. Cool.
Okay, so it looks like we still have, are we allowed to ask questions? We have 3 hands.
Oh, yeah. Cool.
Okay, so Bukama, so on you. You can ask your question. Bukamo, so you'll have to unmute on your side.
Oh, so what if you have to like you have to find like a variable, like let's say x is a variable, and then like you have to find the answer. How do you do that?
Okay, so that's like the question we've just done. So have a look at how we did it there. We said that x plus the other angle must be equal to 360. So we basically create an equation for ourselves where we can then go solve for that variable, like you say, that we want to find its value.
Oh, okay, thank you.
Okay, we're going to do more examples, so don't worry.
Okay, thank you.
So we have Tero, we are all yours. Guys, you can also put your questions on the chat. Like this, I can help teacher Sam and then we can go faster. Okay.
Okay. Hello, teacher. I just wanted to find out, it's Tero's mother, I'm attending with her. I just wanted to find out how soon will this video be available on the website for us to really play it back, because she's also still struggling to understand from the beginning. So just so that I can be able to explain what I understand so far, because it makes sense to me, but it's a bit difficult for her.
Okay.
Oh yeah, yes. No, I just wanted to explain to them that this video will be, after 24 hours, it will be uploaded on the network. So you can always go. But I think the more we do exercises, because we're gonna do the same exercises, just put in different manner, and then she will get to understand soon exactly how the pattern goes.
All right, thank you. Thanks, guys.
Okay, guys, so let's have a look at another one, and hopefully those of you with hands still up, your questions will slowly get answered as we go along. So let's have a look at this second example here. So now we've got a couple more angles. Now what we need to remember is that if I go and have a look at what I've been given, I can see that all of these angles come from a central point. So this pink dot over here, that is my central point, and all of these angles form around that point. And so basically, if I were to take all of these angles and add them up, so if I were to take the x plus the 70 plus the 60, and we'll discuss what that square means now, and plus that other angle, I must get 360 degrees, because what has happened, I've taken all of the angles and I've added them up to get a full circle. Okay, now very quickly, in geometry, whenever we see an angle that has the square in it, can anyone tell me, you can pop it in the chat or you can raise your hand, can anyone tell me what that square means? What does that mean in geometry? Okay, Kayla, I saw your hand go up. Do you want to answer for us?
Yes, ma'am.
Tell me.
It means that it's a 90-degree right angle.
Awesome. Yes. Well done. Thank you. Right, exactly, guys. So whenever we see that that little square, it is telling me the size of the angle without actually writing down the numbers. So whenever you see that square, as Kayla's just said, it is a 90-degree or it's a right angle. So that's really important. So now I know that if I take x plus 70 plus 60 plus 90, and I add them all together, I must get 360 degrees. Now again, guys, if you're more comfortable with this, you can probably jump straight to your answer, and that's absolutely fine. But let's just discuss how we would deal with this. Now, there's many different ways you can go and tackle this. What I'm going to do is I'm actually going to add the 70, the 60, and the 90 together just to make it a little bit easier to work with. So when I add those three values together, I get x is equal to 200, oh no, sorry, x plus 220 degrees must equal 360. You don't have to add them together, but it's just going to make my life a bit easier. Right, now what I must remember is that I've made a statement, so I actually need to give a reason for the statement. And remember, angles round a point. That is the reason why I'm saying if I add all four of those angles up, we will get 360 degrees. Okay, cool. So now we just have to solve this equation. All I need to do is I now need to subtract 220 from both sides. So minus 220 minus 220, because remember, I'm solving for x. And so x is equal to 140 degrees. All right, now this makes sense. If I go and plug that 140 back into my diagram, if I say 140 plus 70 plus 60 plus 90, I get 360 degrees because all of those angles are around that circle, that central point. And because it creates a circle, I have to get 360 degrees. Okay, well done. I saw a lot of 140s on the chat. Well done.
Hey guys, it's time for the screenshot. And remember, those of you that still have their heads up, I told you guys that while Teacher Zep is talking, you are allowed to put your question on the chat. Like this, we can answer them directly, or I can type them, or Teacher Sam can even see them and answer your question, or we can take your hand when it's this kind of time. But just know that it will take a while. So it's best to make sure you cover your ground, put your question on the chat, and raise your hand. Okay. I hope most of you are starting to get this and to realize what's going on here. Hey, Teacher Sam, are you ready for questions? Can I take them?
I am.
Okay. So I'll go with Hassana. I'm not sure if I'm pronouncing your name, and welcome, a newbie. What's going on? What's your question?
I wanted to ask if are we also going to do geometry triangles, because that's what I'm struggling with.
Yeah, we will eventually get there, but right now we're doing straight lines or angles and straight lines.
Oh, okay.
Okay, so I just want to add to that, Hassana. So I've already answered actually your question on the chat. So my name is Yolanda. Whenever you see a name written there on the chat, Yolanda, you must always follow, okay? If you are listening, it's okay, but you can follow the conversation and see if I have answered your question or not, okay? That goes to everyone. I'm the TA helping you with the chat. Watch out.
And guys, on that, you can direct message Yolanda if you have a question. Instead of putting in the chat for everyone, you're welcome to do that. You can direct message me as well. I just might not see it if I'm busy with a question. So what you're welcome to, just you can do both. All right. And guys, please just in the chat, we're talking about maths and maths only. Okay. So your questions are related to maths.
Okay, we have another question. Seko, we are all yours.
Afternoon, ma'am and fellow
Hi.
students.
Hi, Tleko.
Hello, Seko.
Do you have a question for us?
Yes, ma'am.
Okay, tell me.
So, ma'am, where did you get the 220?
Okay, so the 220 is basically just from adding the numbers. So when I'd written my equation, I had the 70, the 60, and the 90. And basically, it's just a lot of numbers. And because they're all numbers, I can add them together. So if I add them up, I get 220. I'm just simplifying the one side of my equation for myself. You don't have to, but it's just a little bit easier to then work with. Does that make sense?
And the negative 220 on top?
Okay, so that was just me saying, and maybe it would have been better to put it in a different color. That was me just saying, let me take this off, that if I now want to take this 220 and move it over my equal sign to get X alone, what I actually need to do is I need to subtract 220 from both sides. Because if I think back to solving equations and my inverse operations, that is the way I move things over my equal sign. So in doing that, those two essentially cancel, leaving me with the X. And the 360 minus the 220 gave me that answer of 140 I was looking for. So basically, it's just the inverse operations to solve my equation.
Thank you, ma'am.
Pleasure.
Okay, so we have, guys, I think I'm going to take one more because Teacher Sam wants to continue. I see that. Don't say we are all yours. Bukamo, so please put your question on the chat.
I'd just like to know for the for question number 2, obviously there's different angles as you carry on. How do you specifically know that it's a revolution?
Okay, so basically I know it's a revolution because if I follow the path of all of these angles, and basically what I mean by that is if I take the 90 and the 60 and the 70, oh golly, okay, I'm going to do that again. That wasn't very nice. Right. the 90, the 60, the 70, and the X, if I take all of those angles and put them together, it's forming one circle. And so that's how I know I'm working with that revolution. If it didn't, and we're going to do reasons where they don't necessarily form a circle, if it didn't, then I would have to use something else. But in this case, because it goes all the way around to get a circle, I know I'm working with that revolution.
All right, thank you so much.
Cool. Awesome. Okay, guys, we're going to do one more and then we'll take a little break, okay? Because you guys are doing really well, so let's try another one. So here we've got 3 angles, and sort of like Nontle has just asked, how do I know I'm working with a revolution? Well, let's see. I can see that all of these angles are sort of stemming from one central point, this point over here. And so if I now say, okay, well, if I take this 110 plus the X plus the 140, well, what I've actually done is I've created a circle for myself. And so I know I'm working with 360 degrees. So I know that X plus 110 plus 140 must give me 360 degrees. And again, remember your reason. You've made a statement, so we now need to give a reason for it. Angles, oh, golly, Miss Molly, angles round a point. Okay, your reasons that you learn in school might look a little bit different to mine, but as long as you are getting across the reason that there are angles around a central point, you sort it. Okay, so now we do a very similar thing like what we did in question 2. If you want to, you can add the 110 and the 140 just to make your life a little bit easier. If I do that, I've got X plus 250 equals 360 degrees. And now I need to solve my equation. So I need to subtract 250 on both sides. So X plus 250 minus 250 is equal to 360 minus 250. Now, guys, you do not have to show this minus 250. So this bit on both sides, you don't have to show it. All it is the inverse operation to solve for X. Righty, so if we now say 360 minus 250, I get 110 degrees. Now remember to put that little degree, the little open circle thing. It is part of the answer because it's the size of your angle. That degree is basically the unit in which we measure angles. So do you remember it? And then we've got our answer of X being 110 degrees. And you can always check yourself. If you add 110 plus 110 plus 140, you should get 360 degrees. Right, now the 250, remember again, guys, all that's happened for me to get 250 is I just neatened up this side. So I added together the 110 and the 140. That's it. You don't have to add them. I'm just neatening it up for myself for my working out. Okay.
Okay, it's time for screenshots, my babes. Time for screenshots for those of you that are not done with this question. So, Bukaboso, you have a question. We are all yours.
Oh, so I wanted to ask, when are we gonna do integers? Because I've been struggling with that for too long.
So guys, I'm pretty sure, and Yolanda, you can correct me if I'm wrong, the course outlines are all on the website. I am pretty sure integers was done at the beginning of the year, so the video should be available on the website that you can go and watch. So they actually are already on the website for you.
Oh,
Yep.
okay.
I can definitely tell you that integers is there, equations should be there already. So guys, every single topic that you're looking for that you don't have or that we're not doing at this moment, what you can do is that go on the website, check exactly what topic are you looking for. If you're not finding it, then it means we are still going to do it. But in most cases, everything that we have done is from term 1 and term 2, and now we're just focusing on geometry, okay? So everything from the start of exponents and everything that you might looking for, it's already there.
Exactly. Okay, guys, so we're going to take a little break. Basically, you can get up, you can stretch. If you need to run to the loo or get something to drink, you can quickly do that. If you are new, our brain breaks basically consist of my wonderful maths joke, and then just a little brain teaser sort of thing for you. So you can see here, I've asked, can you solve this? And basically what I want to know is the value of the cat, the pig, and the donkey. And then there's an expression at the end. Your breaks generally a couple minutes. We don't do long breaks because we do need to obviously get our stuff done. So you can have a look there. If you can't do it, or if you just aren't feeling up to solving the problem, that's absolutely fine. It's just to give your brain a break from the geometry that we're doing before we carry on. Okay, so I can already see some answers coming in on the chat. I basically have a real life cat here. So here's one cat. He's being a little bit of a brat. And
So cutie. Such a kitty.
he's a mommy's boy, so he's crying at the door because I'm trying to teach and he's not involved in the lesson.
That's so cute.
Oh my gosh, now he's stuck in the headphones. Outside, please. Okay, guys. Like I say, get up, stretch, move your body, make sure that you are getting all the blood to your brain every time. He is very cute, but let me tell you, he's very needy. He also has a sister somewhere, but she's probably doing her own thing. Okay, I'm liking some of the things I'm seeing so far. Okay, so I'm going to sort of help a little bit here. What we can see is that the cat is 10, and I know the cat is 10 because I've got 3 cats being added together to give me 30. So if I'm adding 3 of the same thing, the only way I'm going to get 30 is if all these cats are 10. So every time you see a cat, you can now have the number 10. Okay, so hopefully that helps a little bit. That should hopefully help you get the pig. Right, and guys, I can see people asking, when are we doing this section? When are we doing that section? You need to go and have a look on the website to see what has been done. And as Yolanda said, if it isn't on the website, then it is probably still coming up. And so we will eventually get there. Okay, so right now we're dealing with geometry. A lot of the sections have been done, so go and have a look on the website there to see what has been done. Okay, I'm seeing some answers for pig. So the pig, we know that if we look at the second step here, when I add 2 pigs and take away a cat, I need to get 22. Now I need to think carefully about this. I'm adding 2 values together, but then I have to take away 10 in order to get 22. So now I need to think, okay, well, if I add 10 to 22, I'm sitting at 32. And the reason I'm thinking of that is because if I have 32 and I take away 10, I know I end up with the 22 that I want. So if these 2 pigs should equal 32 together, well, then by themselves, each pig is 16, because 16 plus 16 is 32. And then minus that cat, so minus 10, I should get my 22. So anytime you now see a pig, you know it's 16. And then your donkey, we can find, because now we know that the pig is 16. And if I take away the donkey, I need to get 11. So this donkey must be 5. And so now when we see the donkey, we know we're working with a value of 5. And now for that final expression, all I do is add them together. So 10 plus 16 plus 5. And as I saw, 31 is your answer. So guys, again, don't stress if you don't get it. That's absolutely fine. It's just something to like make your brain work a little bit differently to the geometry. Well done, guys. I saw lots of 31s. Well done. Okay. Right, Amahle, is it a question about this? You can ask if you'd like.
Hi, ma'am.
Hi.
Okay, so for the second one, the one where there's 2 pigs and a cat.
Yeah.
Wouldn't we say 22 minus 10?
So if you think of it like an equation, I know that whatever the 2 pigs are, I have to take 10 away from it to get 22. So that would mean if I add 10 to 22, then that will give me the number I started with. So the number of those 2 pigs together before I subtracted 10. So I actually add 10, and it sort of goes back to like solving equations and using opposite operations. And so I have to add the 10 so that I know what I started with before I took the 10 away. Does that make
Okay.
sense?
Ma'am, because I said 22 minus 10 because of the cat, and it gave me an answer of 12, and then I divided by 2.
Okay, well, let's check. If you said 6 plus 6 minus 10, 6 plus 6 is 12, and 12 minus 10 is only 2. So the pigs can't be equal to 6. They need to be equal to a little bit more.
Okay.
Okay, so you can always double check by substituting back if you need to. Okay.
Thank you, ma'am.
Cool. Right, guys, so let's carry on with some of these geometry questions. Here's question 4, right? So let us have a look at what's going on here. Again, what we have a look, or what we can see here is I've got a central point. Let's find a nice color. I've got a central point around which I have 3 angles. But if I add the 2x, the 70 and the 2x, I should get 360 degrees because all of those angles go around in a circle to give me 360. So I can set up my equation for myself. I know that 2x plus 70 degrees plus 2x must give me 360. And remember, guys, you have to put a reason. Angles around, got to spell there, a point. In geometry, it's like the one thing you just have to remember to do. You have to give a reason. Right now, in solving this, remember our goal is to find the value of x, just x. So it's like solving an equation. So if I have a look on my left, I've got 2x plus 70 plus 2x. So what I hopefully see is that I've actually got some like terms here. 2x and 2x are like terms. So when I add those together, I get 4x plus 70 is equal to 360. Now, guys, because this is a continuation of my working out, I don't have to keep rewriting my reason. You'll see in all of them, I didn't rewrite the reason for each new step. Once I'd made the initial statement, that's it. If I carry on my working out, that's all I need to do. So now I have to go and use those inverse operations. So I'm going to subtract 70 from both sides. So 4x plus 70 minus 70 is equal to 360 minus 70. Remember, you don't have to write those minus 70s on both sides if you don't want to. It's just me showing you the inverse operation to solve the equation. And so what I have is 4x is equal to 290 degrees. Okay, so I now need to solve for x. If I think back to my equations, the way I solve for x is I now need to divide both sides by 4. And 290 divided by 4 is equal to 72.5. Sorry, I shoved my screen down a little bit there. So x is equal to 72.5 degrees. Now it's okay to get a decimal for an angle. Generally, your decimal will be a half. It won't be any like weird long decimals, but that's not to say it can't be. So it's okay that we got a decimal. In this case, even though we don't really like decimals, we will write it as a decimal rather than an improper fraction or a mixed number. So 72.5 degrees is the size of my angle, x. Okay, so all 3 of those angles added together give me my 360 because of angles round a point. Okay, and we got that decimal because if we say 290 divided by 4, I get 72.5. And I divided by 4 because remember, I want to get x alone. Now what you can do, guys, if you wanted to, you could go and substitute that value for x back. So both of these angles are 2x. So if you now say 2 times 72.5, you can get the size of those angles. So this angle is 145 degrees and this angle is 145 degrees. So you can substitute your answer back once you've got x to find now the size of the angle, but the whole point was to find x. Alrighty. Okay, and I got 4x, remember? 2x plus 2x is 4x.
Okay, we have some questions. Are we allowed to take some questions? I see that these will be the last thing that we do
Awesome.
for today. Okay, Rory Song, we are all yours.
Hi, ma'am.
Hi.
Ma'am, I wanted to ask, by the where we had to change it into a fraction, right, ma'am? So
This
when we
point
had,
over here.
yes, ma'am, when we had to change it into a fraction, when we had to also use the variable into it. Ma'am, I was a little bit lost because it was 4x over 4. It was 290 degrees over 4.
Okay, so let me actually rewrite this step because let me break it down a bit more. So what I have here, let me just put that back, 290. So what I have here is that 4x is equal to 290 degrees. Oh, is that my headphone? So what I've got is 4x equals 290. Now I just want x, okay? So if I just want x, I need to somehow get rid of that 4. Now, because 4 is being multiplied, in my next step, what I'm actually going to do is I'm going to divide by 4, because 4 divided by 4 is 1. But then I need to do the same thing on the other side of my equation because I need to keep that equation balanced. And so when I divide 290 by 4, that is where I'm getting my decimal answer of 72.5. I'm not rounding up or anything like that. I'm just going and doing that. So when you say 290 divided by 4, I get my answer.
Sorry to just your headsets are like us for some reason.
Thank you, ma'am.
Is that better? No.
It could be that it's not yours. Teacher Sam, are you still there? Teacher Sam? Hello? Teacher Sam?
Okay, can you guys hear me better now?
Yes, now we can hear you better and clear.
Okay, I don't know. Right, I'm going to explain that again because I don't know how much you heard. Right, so from this step of 4x is equal to 290 degrees. Remember, my goal is to get x alone. That's what I want. So in order for me to get x alone, I have to get rid of that coefficient of 4. So the only way for me to do that is to divide both sides by 4, because 4 divided by 4 essentially cancels, leaving me with the x. And then 290 divided by 4 simplifies to 72.5. And like I say, we write it as a decimal here because it's the size of the angle. And so we're not going to use fractions. We're not going to use mixed numbers. We leave it as a decimal. So the reason I divided both sides by 4 was to get my x alone. Okay. Yeah.
Okay, so on that note, I think I'm gonna just run the poll. Is that okay? Because we're running late to the other class.
That's fine. Okay, guys, we are going to do more of this on Wednesdays. So please make sure you're here. We're going to do more questions like this. But yeah, just keep working. You guys are doing well. Keep asking your questions and we'll get there. Cool.